Year 8, welcome to our second lesson this week. Please make sure you have completed the first lesson first. Okay, so what we're going to do is we're going to have a look at continuous and discontinuous variation today. And we're going to describe the difference between the different types of variation, and we're going to be plotting some graphs. There is another video that I've made to watch, and I will direct you there when we get there. Okay, so let's have a little look. We've already talked about variation. It's a difference between individuals within a species, and we talked about the fact that it can be caused by inherited or environmental factors. So I just thought I'd just recap this for us. So let's have a look. Inherited factors. Here we've got the Hemsworth brothers. You've got Liam there, you've got old Thor himself, Chris Hemsworth, and you've got the other one who I don't think is an actor at all. You have a look at them, they have very similar features. So Liam and Chris here, they've both got very similar noses, similar face shapes. All three of them have got similar face shapes, but they're all very different heights. And these are all things that are environmental factors. So height, eye colour, sorry, not environmental, inherited, eye colour, face shape. Yeah. So the brothers here have all got lots of characteristics in common. You can tell that they're brothers. Then let's have a look at old Khal Drogo himself, old Jason here. He has got some really outstanding environmental factors. So environmental factors are caused by outside factors such as the environment. And one of the biggest things about Jason is he's got a big scar above his eye and his eyebrow here, and it's very it's very noticeable, and it's one of the features you can really recognise on him. And scars are an example of environmental factors. I think he got a bottle or some glass in his eye above his eye when he was a lot younger. Another one is actually hair length. So if you have a look in this picture here, he's got very long flowing hair. I'd do anything for amazing hair like that. He's also got quite a long beard here as well. Whereas in this picture, he's actually cut those. So he's got a much more trimmed beard, and he has got much shorter hair. I'm going to put hair length here. Other environmental factors could be how muscular somebody is, how much they work out, how much weight they have, how much, whether or not there's enough foods available for them. Different parts of the world, for example, can show this. So I just wanted to just remind you about what those were. But also, variation can be continuous or it can be discontinuous. I'm going to investigate those terms today. So let's talk continuous variation first. So human height is an example of continuous variation. Okay. And why we say it's continuous is because it has a range. Okay, it could be any number, pretty much. Oops, seem to be pressing lots of buttons there. Okay, let's get rid of that and go again. Okay, so it could be any number. Yeah, so from the smallest to the tallest person in the world. It varies over time. So there's some examples here. You've got height, you've got weight, shoe size, for example, arm span. So what you get is when you're trying to work out variation, you would measure. Let's say, for example, you measured the height. In this example I've got here, you've measured the height of people. You've got some ranges here. And if you measured enough people, you would end up with a curve like this. And this is called a bell curve. It's something which comes up quite a lot. It basically shows you, so on average, this is the height of all the people sampled, because that's the average height for you. So what we've got here, the more people you measure, the smaller the categories you use, the closer the results will be to the curved line. So this shape of this graph is a common feature with continuous variation. Weight would give a similar graph like that. Okay, so key thing to remember: continuous variation is going to be it could be any number at all. Discontinuous variation is more black and white. Okay, basically it's almost like a yes or no answer. So we've got here the example of blood group. Well, there's only 4 choices for that. You're either A, B, AB, or O. You might be positive or negative in there as well, but they're the only blood groups that are possible. There's no values in between them. It's discontinuous variation. Okay. Also sex. You either identify as male or female, or are genetically male or female. Okay. Obviously, we could put in sort of the third sex or gender neutral there, but there's nothing in between those particular categories. Same with eye color. Eye color. You might have blue eyes. You might have brown eyes. You might have green eyes. You might have hazel eyes. You might have grey eyes. But there's nothing in between those. So that's what we mean by discontinuous variation, okay? It's only a limited number of possibilities, okay? A limited number of possibilities. Whereas continuous variation could be any number. Okay, so what I'm going to do now, I'm going to show you how to draw a graph, okay? I know just as a bit of a reminder, and we're going to plot some data about continuous variation. So what I would like you to do is, I would like you to pause this video and then go to the other video that I put in the task, which is called How to Draw a Graph. Watch that and then come back to this video after. Okay, so from the video you just saw, what I'd like you to do is I'd like you to copy and complete the instructions you can see in front of you. Okay, so you need to fill in the blanks, and that'll give you a method on and some instructions on how to plot a graph. So if you can pause the video and do that now. Okay, and here's your answer. Yeah. You draw out two lines called axes. Along the bottom is the x-axis, and you have y to the sky, so the one up to the side is the y-axis. Label your axes. The x-axis is normally the independent variable, and the y-axis is the dependent variable. And you don't have to write the number 0 where your axes meet, but generally it's good practice. Scale needs to go up in equal amounts with equal spaces between the numbers, and the last number in your scale needs to be higher than your last results. So pause and correct anything you need to correct. Okay, so what I'd like to do now, I'd like you to write out these statements about graphs. Problem is they're wrong. Okay, so I'd like you to actually write them out, but correct them as you go along. So pause the video now and have a go at that. Okay, so let's have a look. So the y-axis is along the bottom and the x-axis is up the side. Well, actually, they're reversed. So the y-axis is along the side or up the side, and the x-axis is along the bottom. The control variable goes on the x-axis. It's not the controlled variable, it's the independent variable. I'll put it there. It can, the scale can start at 0. You can also start it further up if you really want to. The scale should go up in different numbers each time. It should go up in the same amount, the same number each time. So 5s, 10s, 20s, 50s, 100s, but it must go up the same each time. And the scale should have 1 or 2 centimeters between each number, while actually it should have the same amount of space, or the same amount between each number, so that it's going up in an even amount. So, for example, 1, 2, 3. Obviously, mine isn't quite perfect. 4, 5. Okay, you do some graph paper, it would be. Okay, so pause the video and correct anything you need to correct now. Just a quick activity for you to do here. So identify the number that is being pointed at each scale. So this one here is going from 70 to 80. You've got 1, 2, 3, 4, 5 spots in between. So it's going to go up in 2. So that would be 72, 74, and here would be 76, then 78, and 80. And on this one, we've got 15 and 20. So we'd go 15, 16, 17, 18, 19, 20. Okay, so last thing I'd like you to do, I think, is to have a go at drawing your own graph. So I'd like you to draw the graph and plot the data that you can see below. So just as a quick reminder, the independent variable is normally in the first column here on the left, and the dependent, so we're looking at the amount of water and the number of leaves that grow is here. So think about which axes you're going to put each of those onto. So pause the video. If you can either do it on the computer, so you could do it in a Google slide, or if you could, I've added some graph paper to the task, so you could either print that off if you wanted to, or you could use squared paper. Okay, so pause the video and have a go at that. Okay, so hopefully you've had a go at that, guys. Please make sure that you do upload a copy, either a photo or a slide of your graph there. And yeah, and that's it for this week. Please make sure after this you go and you do the quiz, okay, because that forms part of my assessment, and you upload any work that you need to. Okay, guys, have a great half term, or if you're doing this after half term, I hope you've had a great half term, and I will speak to you soon. Thanks, guys. Bye bye.